Okay, so these are the longer ones. So 16, we get a triangle that is like this. The arrows go like that, and it's like this. So A is here, B is here, and C is here. And we are asked to find the dot product of A plus B dotted by A plus B plus C, if I remember. So when doing the dot product, actually to start off, we're going to have to do A plus B. How do we actually do that in terms of vectors? We don't have these side lengths, right? But we're given in the question that they're unit vectors, right? So usually when adding a vector, we take our coordinates of the two vectors like this, and we just add them together. Add the first two, so x's, then add the y's, right? We don't have these coordinates. We actually don't have anything about these other than the fact that they're 1. But the fact that they're 1 is actually really important. So I'm first going to show you what I'm doing. You're not going to know why I'm doing it yet, but I'll show you why after and it'll make sense. This is an equilateral triangle, so automatically we know that each angle is 60 degrees. So what we're actually going to do is we're going to take these vectors and plot it on our Cartesian plane. So A goes like this. We know that this angle here, because A to C is 60, so that we know this whole angle here is 120. If we plot B on the Cartesian plane starting from the origin, we get something here. And what do you think that angle is? It's 60. C, if we plot it, you'll notice it goes right along here. Okay, what can we do with this? When you think about it, we know these are unit vectors. They have a magnitude of 1, all of them. This is where we can use our unit circle. If this vector has a magnitude of 1, we know every line that connects from the center to the outside of the circle, so the radius is going to be 1, we can find these points using our unit circle. So we go to our unit circle, find the one with the angle 60, and we see that that point is 1 over 2 root 3 over 2. This one likewise is even, but it's in the opposite direction, negative 1/2 root 3 over 2. And this coordinate here is going to be negative 1, 0. So this is our A, this is our B, this is our C. Now we can actually do A plus B. A plus B is going to be negative 1/2 root 3 over 2 plus positive 1/2 root 3 over 2. Negative 1/2 plus 1/2 cancels out to 0. Add these two together, you're going to get 2 root 3 over 2. You'll see that the two 2's cancel, so it's just basically root 3, like that. That is our A plus B. Now we need A plus B plus C. We already know A plus B is this right here. So now we just got to add C onto it, and C is negative 1, 0. Add up the first two, that should say 3. Add up the first two, you get negative 1. Add up the second, you get root 3, like that. Now we have our 2 that we have to dot together, because remember overall we were taking this and dotting it by that. So we're going to have 0 root 3 dotted by negative 1 root 3. Multiply the first together, you get 0. Root 3 times root 3, it is just 3. You add those together, and your answer is 3. I'm not going to lie, I asked Ms. Schaefer a little bit of help on this one, because putting it on the Cartesian plane I didn't think about, but that is the way you do it. And why do you do it? Because whenever adding vectors, you don't add the magnitudes, you actually need the points. So you got to figure out some kind of way you can get those points. Generally, go to here if they're unit vectors. All right, let's do question 17. So we have A is 1, B is 2, C is 3, and we know that together they add up to 0. So basically our displacement is 0 for physics people. We can't make this into a triangle. It's just not physically possible. If we take our C vector, let's just call it 3 and go this way, you'll notice that 2 plus 1 equals 3. So if we have another vector here, you notice you can't bend those to make them connect, or they'll just be like this. They're just stuck. They're not long enough to actually connect to reach a triangle, because 2 plus 1 is 3. It has to be bigger than 3 by a certain amount as well. But since it's exact, you know automatically it's actually not even a triangle. It's just 3 lines like that. So this is our C vector. This is our b vector, this is our a vector. And they are parallel, but opposite. They're going the opposite direction because we're starting here and moving here, and you see how tip to tail, like that, it goes back to 0. Now we have to find, we got to do a dot b added to a dot c added to b dot c. So we're not adding vectors here. We're adding the dot product. And the dot product is going to give you a scalar anyways. So you don't need these coordinates. We need to somehow dot them. Now dotting, you either use the coordinates on the one side, like AB, whatever, or you use the magnitudes and the angle. We don't have coordinates, you can't find it. But if your mind didn't go to that, you'll automatically know the second side. We do have our magnitudes, so that's likely important. They aren't unit vectors, and we actually do have angles. Starting with a dot b, it's going to be magnitude of a is 1, magnitude of b is 2, and what is our angle between a and b if we add them tail to tail? We have a and b. You'll notice it is a completely closed angle. Your angle is just 0, cosine of 0. So cosine of 0 is 1, so you're going to have 2 times 1, and that is going to be 2. Same process for 2. You guys should probably try to pause the video and try this and see if you got it right. So a is going to be 1. C is going to be 3. Now if I add them tail to tail, you'll see that your a goes here. And our angle in the middle isn't 0, it's actually 180. It's going to be the cosine of 180, which is negative 1. So you're going to get 3 times negative 1, negative 3. Keep that aside. And now we finally have to do our b dot c. So our b was 2, and our c is 3. 3. And again, if we add these, it goes like that. Angle is 180 again, which is negative 1. So we're getting 6 times negative 1, which is negative 6. So you'll see we have 2, negative 3, negative 6. So a dot b is 2. A dot c is negative 3. And b dot c is negative 6. And all of those together are negative 7. And for our final question, question 18. Credits to Alan and me for this one, but kind of mostly Alan. This is not the answer in the back of the textbook. The answer doesn't make any sense, but this way is so much easier. We're trying to prove that d dot a equals 0. Don't know why the textbook started with that whole other thing. Start with this, honestly. Get that other side to come to 0. It's so much easier. So d dot a. It gave us that d was the same thing as b minus c. So we can go like that. It didn't give us any other thing for a, so we're just going to leave it like that. That makes sense so far, right? We just changed d, left a. Now, we have b and c. I don't want that c because we actually know more about c, so I'm just going to incorporate it in. Maybe it works, maybe it doesn't, we'll see. So b minus, and now c we know is b dot a, and bracket a like that. And this is all dotted by a. Now somehow we have to say that this equals 0. So I want you guys to look at this a bit differently. Look at this as one term. This whole thing is another term because these are all multiplied, right? Dot, but like it's still one term. And this is one term. What we have here is kind of like an x minus y with a number out here. Let's just say 5. How would you do that? You would do distributive property. It's 5x minus 5y. So let's look at it in terms of that. But instead of obviously putting the numbers beside each other, they're dotted. So d dot a. We're going to take our a and b first. So this term multiplied by that term is just b dot a. Now we should take our whole second term and dot it by a. So it's basically going to be our b dot a dot a. This dot by a, that dot by a. And I forgot the little subtraction right there. You're going to start seeing something happening here. Start to see something happening. This, b dot a minus b dot a, they cancel out. So we're left with a dot a. No, I'm saying the wrong thing. Don't mark that. I forgot these are connected. That's not how it works. So we can't just cancel them out. It's going to be b dot a minus b dot a, but that's connected to this a dot a. It was given in the question that a is a magnitude of 1. And like before, a dot a is the same thing as the magnitude of a squared, the magnitude of 1 squared, which is just 1. Like this, or since it's 1, we don't even have to write it at all. So basically, this whole thing attached to it, which is causing me a problem before, is actually canceled out because the fact that a is 1 and the fact that a dot a is the magnitude of a squared. So this is what we're left with. So I got a step ahead of myself, but now you see b dot a minus b dot a equals 0. And I hope